Okay, we're going to talk about the exponential growth and the decay. Growth and decay. All right. Now, this function looks like the same. It's f of x equals a0 and e k t. Now, this a0 is the initial amount. How much you have at the very beginning. Or f of 0 is just that a0. And look, x. Or f of t. Here's x, so that's a function. Now f of 0, if here is 0, 0 times k is 0, e to the 0th power is 1, so a0 becomes f0, right? So that's the initial amount. And then k, e we know, e is a constant, and this is the independent variable. So k, when k is greater than 0, then f of x is an exponential growth function. And when k is less than 0, then f of x is an exponential decay function. All right? If you want to graph that, and that x by the x is the power here, and our x is always greater than 0 because growth and decay always start from 0, so this is x, or t, whatever you want to use, it's just the independent variable, and here is y or f of x. Okay, for the growth function, it looks like this, and this point is a0. Okay, so that is when k is positive. And when k is negative, so it's starting from here. I should use, let me use different color. So the other one is a0, and it goes like that. Okay, so this is a decay function. That's what it is. Okay, I'm going to just give you one example to let you understand this. In 1970, the U.S. population is this. It's 203.3 million. Okay, and by 2020, the population is 331.0 million. Can you find the exponential growth function that models this data go from 1970 to 2020? Can you find it? Okay, that's the first question. And after you get the math model, then I'm going to ask you the second question. So the first question is, because this is the t, okay, so let's assume that x or t, x is the number of years after 1970. So that means at the very beginning, 1970, my a0 is 203.3. That's the initial amount. And because it's growing, so it's a growth function, so my y equals, remember a0 e k x, remember this one? So we have this y, when the x equals, in 2020, what will be the t? The number of years after 1970. So this 2020 is, I think it's 50 years later, isn't it? So that means when x equals 50, y is 331. All right, now let's plug in all the numbers we have there. Okay, the model looks like this. The model comes like a 331 0.0 I don't really need to write, and then 203.3 EK times 50. The most important one, in this case, we're looking for this K, which is like solving a exponential equation. So we divided by 203.3 both sides. So we have 331 over 203.3 equals e to 50k. Okay, and then can I go ahead and take natural log? I take ln on both sides. So ln 331 over 203.3 equals ln e 50k. And this is the natural base e, so that will be just 50k. Okay, so I'm good enough. I got k equals this ln 331 over 203.3. In your calculator, you can do this division and take natural log, and then you divide it by 50. Okay, guess what? The answer is roughly 0.01. Therefore, your equation or your math model looks like this. Y equals 203.3 E 0.01 T. This T is how many years after 1970? Okay, once you have this model, I ask you when you think the US population will reach 400 million. 400 million, which is here. And so we're looking for T to make this guy to be 400 million. So let's solve it. So 400 million equals 203.3 and then E 0.01 T. Again, I'm going to divide it by 203.3. So 400 divided by 203.3 equals E to 0.01 T. Take natural log. So my ln of the left side 400 over 203.3, and the right side will be ln E 0.01 T. And what is this? Ln and E get canceled out, is 0.01 T. So we get ln this and equals 0.01 T, so we just need to divide it by 0.01 and use the calculator. Guess what? You find this is 67.7. Let's take the whole number. I said 68. What does that mean? That means 68 years after 1970. So you have to add to 1970. You add to that, the answer is 2038. So roughly in the year, by the year of 2038, US population will be somewhere around 400 million. So right now, we still have some time, so we can see whether this model is correct or not. Okay, so generally speaking, this is what you need to know, and you're using one model for either decay or growth, as long as it shows that the change is an exponential function. Okay, so this is fairly short, huh? That's the end of this part.